In this video, we're going to talk about logarithmic functions. So I've kind of alluded to this, the fact that there is an inverse to an exponential function, and it's called something specific or different. And let's take a very basic exponential function. Let's take f of x is equal to a to the x, where a is greater than 0. And if we take this function where a is greater than 0, and we've tried to find the inverse, which of course means the first thing we need to do is find the corresponding equation. So y equals a to the x. We are then reversing or switching the x and the y, so we'll have x is equal to a to the y. We can use this equation as it exists for simple values. So for example, if I had something of the form, let's say 4 is equal to 2 to the y, we could input the value 4 here and determine what y must be. So our output, we could figure out that y must be 2. But what if, for example, that we have, again, this x equals 2 to the y, but instead of an input of 4, let's say I have 1.2 is equal to 2 to the y. Well, now we really don't know what y could possibly be. We can't, it's not going to be an integer, and so this presents a problem. So what we tend to do is we use this new function called a logarithmic function to help us solve problems like this and figure out what y can be. So the definition of a logarithm is y equals log base a of x if and only if this is true, and it is if x is equal to a to the y, which we've already stated before. So this is this equation, y equals log base a of x, is true if and only if x is equal to a to the y. This relationship is going to become very important for the following problems. One quick thing to note about this function is that x is always greater than 0. So for these two problems, we are going to change each of these from an exponential equation or statement to a logarithmic statement. And it's using the relationship before. Remember that x equals a to the y can be converted to y equals log base a of x. And that relationship is what we will use for actually the next several problems. So with that relationship, we can then figure out that 2 is my base, so it must be a. This, even though it says x, is actually my y, and this value, 7.2, is actually my x. So now converting that over into log, we now have x equals log base 2 of 7.2. And the way you ask yourself this is saying 2 to the what power is equal to 7.2. And that's what logarithmic functions can tell us. Going to number 2, again, my base is a, just happens to be the same variable. My 3 in this case is y, and my 2.1 is x. And again, I'm looking at this function up here to determine the relationship here. All right, so converting that now over to the logarithmic equation, we have 3 is equal to log base a of 2.1. And you're saying to yourself then, to read this, you say a to the third power must be equal to 2.1. Okay, and we can say what to the third power is equal to 2.1. We're going to change each of these statements from a logarithmic statement into an exponential statement, and it's important to remember that this relationship exists. X is equal to a to the y, and this can be converted to y equals log base a of x. And so using that information, we know that 2 for number 3 happens to be a, we know that 8 happens to be x, and we know that 3 happens to be y. So then we have 8 is equal to 2 to the third. And we can't actually verify that because we don't have variables. 2 times 2 times 2 does in fact equal 8. So again, you read the logarithm by saying 2 to what power is equal to 8? Well, 2 to the third is equal to 8, and we can rewrite that in this exponential statement here. All right, going to this next one, we know we see the base a, which happens to be a in my equation above. We see 3 has to be my x value, and 6 happens to be my y value. We can then rewrite this as 3 is equal to a to the 6th power. For the last two problems, we are going to actually use the relationship we defined above for the previous 4 problems to help us solve or find the exact value of these logarithms. We're going to do this without a calculator. You can actually do this with a calculator, but you need to know how to do it. It's not something you can just plug into your calculator. So it's a property that we're going to learn later on. So knowing our relationship one more time, the fact that we know x equals a to the y is the same as y equals log base a of x. You're probably getting tired of me writing that, but that's the basis for all these problems so far. So I'm going to use that relationship we've been discussing for the last several problems to help me solve this. The first thing I'd like to do is set this equal to something. I'm actually evaluating this. I want to see what this equals, but I don't know what it equals, so I'm going to choose a variable. To be consistent though, since on the right hand side here you see that my y is equal to log base a of x, I will choose y as my variable. It doesn't really matter which variable you choose. I'm just going to choose that for consistency reasons. So now I know that my 1/3 is my base a, and I can see that 9 is my x value. So going ahead and converting it over to exponential form here, I see that I have 1/3 to the y is equal to my 9. Now I'm going to try to use what I know. I'm going to try to get these to be the same base so that I can set the exponents equal to each other. I'm going to try to get them to be both base 3. So I ask myself, what 3 to the what is equal to 1/3? Well, that would happen to be -1, and 3 to the what is equal to 9, and that would be squared. So now I can go ahead and multiply these two exponents using my property of exponents. So I get 3 to the -y is equal to 3 squared. And from here I can set the exponents equal to each other and solve. So -y is equal to +2, so y must be -2. And you can of course go back and check that into this equation right here to see if that does in fact work out. And I'll show you, we'll see later how to substitute that back or evaluate your log to see if that is in fact true as well. The second problem, we have base a is square root of 5. We have my x value as 25, and again I'm going to set this equal to a variable, and again I choose y for consistency reasons. So now I have the square root of 5 to the y is equal to 25. And again, just as before with number 5, I'm going to go ahead and try to find a common base, so I'm going to choose base 5. It seems like it's pretty reasonable. So 25 squared happens to be 5 squared happens to be 25 rather. And what can I take, what 5 to what power is equal to the square root of 5? Well, that's going to be 1/2. So 5 to the 1/2 is the same as square root of 5. I'm going to go ahead and multiply these two exponents using my property of exponents. So I get 5 to the 1/2 y is equal to 5 squared. Set the exponents equal to each other. I have 1/2 y is equal to 2. Solve that for y, and you get y is equal to 4. All right, so that's how you evaluate a logarithmic expression without using a calculator, and that's when we can find a common base. Now we will see problems later on where we don't have a common base, and so we'll have to use a different strategy to solve these.
You're awesome.